Hello students, welcome to the class. In today's class, I will continue from the last lecture and we will solve 5 more numericals. Okay. So the question number 16 is an infinite number of charges each equal to 4 microcoulomb are placed along x-axis at x equal to 1 meter, 2 meter, 4 meter, 8 meter and so on. The total force on a charge of 1 coulomb placed at the origin is, you have to choose out of these 4 options which one is correct. By the way, this question is asked in IIT entrance examination to 1995. Okay, let's solve it. So let's say this is my x-axis, and on that axis this is my origin, that is x equal to 0, and here a 1 coulomb charge is placed, and you have to find what will be the force experienced by this 1 coulomb charge due to the distribution of charges on the x-axis. And the distribution is like at x equal to 1 there will be a 4 microcoulomb charge. At x equal to 2 there will be another 4 microcoulomb charge. At x equal to 3 4 there is, at x equal to 4 there is another 4 microcoulomb charge. Then 6 7 8, at x equal to 8 there is another 4 microcoulomb charge. Then 8 9 10 11 12 13 14 15 16. Then at x equal to 16 there will be another 4 microcoulomb charge, and so on. There will be infinite number of charges, and you have to find what will be the force experienced by this 1 coulomb charge due to this distribution of charges. We can easily find it by using principle of superposition. We know by the method of principle of superposition, if we can find the force experienced by 1 coulomb charge due to the 4 microcoulomb charge at different position individually and add vectorially, then we can easily find the force experienced by this 1 microcoulomb charge due to the 4 microcoulomb charge at different positions, due to all the 4 microcoulomb charges. Okay, let's do it. Then what will be the force? The force will be force experienced by this 1 coulomb charge due to all the charges. Then I can take 1 by 4 pi epsilon naught common for in the expression. Then for the first one, it will be 1 into 4 microcoulomb, that is 4 into 10 to the power minus 6, and this thing will also be common for all in all the terms, in all the force terms. Then I can take this thing also common, right? I can take 1 into this 4 into 10 to the power minus 6, this thing also common. 1 by 4 pi epsilon naught q into q1 q2. So q1 q2 is common for all these things, and divided by r square. What will be the r square? First one will be 1 square, second will be 1 by 2 square, third will be 1 by 4 square, because the distance are 1 2 4 then 8, then next is 16 and so on. It will go up to infinity. Okay, then 1 into 4 into 10 to the power minus 6 into this thing is 9 into 10 to the power 9. Now we have to find what is the value of this expression. You see, this expression is nothing but a GP, right? An infinite GP. And the sum of an infinite GP, you know the formula for sum of an infinite GP. The formula is, for this, the formula is A by 1 minus R, where A is the first term is 1 minus R. R is the ratio, common ratio. See, here the common ratio is 1 by 2 square by 1 by 1 square, 1 by 4. 1 by 4 square by 1 by 2 square. If you see, let me find the value of R from these two terms. That will be 1 by 4 square divided by 1 by 2 square. That will be 1 by 16 into 4. It is nothing but 1 by 4. So the value of R is 1 by 4. And so 1 minus 1 by 4 is 3 by 4, and so it will be 4 by 3. So this term is 4 by 3. So what will be the answer? 4 into 3 is 12, into 4 48, and 10 to the power minus 6 9, it will be 3, or I can write it as 4.8 10 to the power 4 Newton. Okay, so the option A is a correct option. Okay, let's move to the next question. The question number 17 is, charges of 5 microcoulomb, plus 10 microcoulomb and minus 10 microcoulomb are placed in air at the corners A, B, C of an equilateral triangle ABC having each side equal to 5 cm as shown in this figure. Okay, and you have to determine the resultant force on the charge at the position A. That is, you have to find the resultant force on the charge 5 microcoulomb at the corner A. Okay, so this is not very hard question. We can easily find it. Let's say first we will find what is the force experienced by this 5 microcoulomb charge due to that plus 10 microcoulomb charge at the position B. It will be directed along this direction, right? This will be directed along this direction because plus 10 microcoulomb charge will repel the charge at the corner A because it is also a positive charge. And let's say this is F1 and this minus 10 microcoulomb charge at the position C will attract that plus 5 microcoulomb charge along this direction, along the direction AC. Along the direction AC. But the and let me call it F2. But the magnitude of F1 and F2 will be same because see, plus 10 microcoulomb and minus 10 microcoulomb, they have the same magnitude. So the resultant force on the plus 5 microcoulomb charge will be same due to plus 10 microcoulomb charge and minus 10 microcoulomb charge. Okay. So if we now want to find the resultant force, we can easily find it. We can easily find it by completing the parallelogram. This will be along this direction. There will be along this direction. Now, what will be the angle between F1 and F2? Since this is an equilateral triangle, so this angle will be 60, this angle will be 60, this angle will be 60, this angle will be 60. So this is the outer angle, so it will be 60 plus 60, that is, it will be 120 degree, right? This angle will be 120 degree. The angle between F1 and F2 will be 120 degree. Then what will be the value of F? The value of F will be under root F1 square plus F2 square plus 2 F1 F2 cos of 120 degree, right? But we don't know what is F1 F2. Let us find the value of F1 and F2. We know F1, the magnitude of F1 and magnitude of F2 will be same, and it will be 1 by 4 pi epsilon naught Q1 Q2, that is 5 into 10 to the power minus 6 because it is 5 microcoulomb into 10 microcoulomb, 10 into 10 to the power minus 6 divided by distance square. What is the distance? It is 5 centimeter, so it will be 0.05 whole square, because if I convert it centimeter into meter, that will be 0.05 whole square. Then we have to put the values of F1 and F2 here, then we are done. We know what is 1 by 4 pi epsilon naught, it will be 9 into 10 to the power 9, and 5 into 10, it will be 50 into 10 to the power minus 12, and it will be 25 into 10 to the power, it is 10 to the power minus 2, so it will be 10 to the power minus 4, right? So now what it will be, 25, 50, this is 2, then 2 into 19, 2 into 9 is 18, then 10 to the power 9, and if it go above, then it will be 13 minus 12 is 1, so it is 180. Okay, so this is 180. If the F1 F2 is 180, so of course what will be F? Now what will be F? I can type it right here. Then F will be under root 180 square plus 180 square plus 2 into 180 square, because 2 F1 F2, F1 is 180, F2 is also 180. What is the value of cos 120? Cos 120 we can write cos 90 plus 30. Okay, then cos 90 plus 30 is in the second quadrant, and it will be negative, so it will be sin 30, negative sin 30, and sin 30 is half, so it will be minus half, right? So it will be minus half, so it will be minus half. The value of cos 120 will be minus half, so now it will be only under root 180 square, because 2 and half will cancel, it will be minus 180 square, minus 180 square plus 180 square will be cancelled, so it is F equal to 180 Newton. So okay, so the magnitude of force experienced by 5 microcoulomb charge due to this plus 10 and minus 10 microcoulomb charges is 180 Newton, and the direction is parallel to the BC, parallel to BC. We can easily find this angle, this angle will be 60. We can understand, but we have studied parallelogram law. From there is a formula. F2 sine 120, because 120 is the angle between F1 and F2, divided by F1 plus F2 cos 120 equal to, what is F2? F2 is 180 sine 120. Sine 120 is sine 90 plus 30. Sine 90 plus 30 is cos 30, and cos 30 is root 3 by 2. Cos 30 is root 3 by 2. F1 is 180, and it will be F2 is plus F2 is again 180, but cos 120 is minus half. So it will be 90 root 3 divided by 180 minus 90. So it will be 90 root 3 by 90. So it will equal to root 3. So tan beta will be, root 3 is tan 60 degree, right? So beta will be 60 degree. So this angle beta is 60 degree. That is, the resultant force is parallel to the direction of BC. Okay? Okay, let's move to the next question. The question number 18 is, 5 point charges, each of value plus q coulomb, are placed on 5 vertices of a regular hexagon of a side L meter. Find the magnitude of force on a charge minus q coulomb placed at the center of the hexagon. This question was asked in IIT entrance examination 1992. Okay, and this is a very easy question. See, this is a regular hexagon, and the regular hexagon is of side L, of side length L, and 5 plus q charges are put on the 5 vertices of this regular hexagon, and a minus q charge is placed exactly at the center of that hexagon, and you have to find what will be the force experienced by this minus q coulomb charge due to the 5 plus q coulomb charges placed at the different vertices of this regular hexagon. This is a very easy question. See, this minus q coulomb charge will experience a force due to that plus q coulomb charge in this direction, and this minus q coulomb charge will experience a force due to the plus q charge along this direction. And these two charges, these two forces are of exactly equal magnitude and are in opposite direction. So they will cancel each other. And similarly, forces along this direction and this direction will also cancel each other. But see, this plus q charge will attract this minus q charge along this direction, and this force is not cancelled because there is no charge in that position. So this minus q charge will experience only force along this direction, the force along this direction due to that plus q charge only, and due to that 4 plus q charges, the forces will be cancelled out, and this F will be 1 by 4 pi epsilon naught q square by this length square. You can easily find this length. If this is L, then you have to find what is that length. If you can find, let's say this is x, this will be x square. If you can find this length, then it is done. For a regular hexagon, this angle, and this angle are 60 degree. This angle are all angles are same. If these angles are same, so all the sides should be of same length. That is, this is of L length, this is of L length, and this must be of L length. So x equal to nothing but L. So F will be 1 by 4 pi epsilon naught q square by L square. This is the answer. 1 by 4 pi epsilon naught q square by L square, and the direction is along this direction. This direction. Okay.